to know nano. Today we're going to be starting with the basics and talking about what is nanotechnology. Nano is a really popular buzzword these days, but most people aren't that clear on what nanotechnology really is. So today we're going to break it into two parts, nano and technology. Since most people are already familiar with what technology is, we're going to start with nano. The first thing that most people think of when they hear nano is iPod Nano, because it's really popular. In fact, if you look up nano on YouTube, most of the videos will be about iPods. Unfortunately, that's really not the type of nano we're talking about today. The second thing you'll probably hear is little robots, and as cool as that would be, those aren't really a reality yet either. So we're going to move on. What does nano actually mean then? Well, nano is really a prefix, just like micro or milli or kilo in front of kilometer. And it refers to a size. Usually we think of these prefixes in front of meters, for example kilometers, but nanometers and nanoliters would both be valid. Today we're going to be sticking with meters though. In order to get an idea of how small nano really is, we're going to draw a number line from nano to giga, or from 1/1000th of a meter to 1 billion meters. We're going to start in the middle, which by no coincidence is human-sized. Next we'll start going up. 10 to the power of 3 is a kilometer, which we're pretty familiar with, especially from driving around. Once we go up to 10 to the power of 6, or 1,000 kilometers, we're at about the width of BC. However, if we go all the way to 10 to the power of 9, 1 billion meters, or 100,000 kilometers, that's the distance to the moon and back and halfway back again. Going back down from the middle, 1 centimeter is just about the size of a finger, and a pile of papers are about a millimeter tall, so that's all pretty familiar. But once we get down to 0.1 millimeters, or 10 to the power of -4, this is where people can't see objects anymore with the naked eye. And if we go down even further, in between 10 to the power of -6 and a millimeter, or 10 to the -3, there's all sorts of things like sperm and blood cells that we're not really familiar with seeing. Under a micron, or 10 to the -6 meters, is where things really start to get cool. This is sort of the range of light, which is from 400 to 700 nanometers. And just under that, from 1 nanometer to 100 nanometers, is the range that nanotechnology deals with. In this range, there are materials like graphene, a hexagonal lattice of carbon atoms. And it is in this range that materials start to exhibit the weird properties that nanotechnology is famous for, like changing color. Now that we have an understanding of the size of nano, why does it actually matter? Over time, we've gained a better understanding of the structure of atoms and how they interact, which is a big part of what allows us to manipulate things on the nanoscale today. In addition, we have an understanding that when things are very small, different forces are dominant. On the scale that humans live, gravity is a dominant force. However, when things are really small, the more powerful force is actually electrostatic, or the attraction between negative and positive charges. And these interactions play a large role in nanotechnology and in the different properties that we try and take advantage with when we're working on the nanoscale. In the last 50 years, we've also discovered materials like buckyballs, or soccer ball-shaped configurations of carbon atoms that allow us to make incredibly strong materials. Stained glass, which has been around for a long time, also uses nanotechnology, although people didn't realize at the time they started creating it. In fact, stained glass is one of the first examples of real nanotechnology. These days, even though nano still seems really futuristic, there are actually lots of products on the market which make use of nanotechnology. Everything from stronger badminton rackets, underwear that doesn't smell, medication, printing processes, even sunscreen, and of course some electronic components like wires and computer parts. In summary, nanotechnology is really the manipulation of matter on the scale of 1 to 100 nanometers, or in an atomic range, and the exploitation of the unique properties exhibited in this range. Nano is also pretty fun, so check back to find out more about how nano is used in different products and to have nano misconceptions busted.